So today we're talking about direct and inverse variation. And you wrote some things on your file folder that have that talk about direct and inverse variation. So remind me of what the equation for direct variation is. Y equals kx. And for that graph, it goes through the origin, which is the 0, 0 right here. It has to go through the origin at 0. And another vocabulary word for that would be proportional. If a graph goes through the origin, it is proportional. And it has to have a positive slope also. So it's proportional, and it's also called direct variation that goes through the 0. If it goes through any other place on the y-axis, then it's not direct variation. We also wrote down that the x and y are both increasing. That indicates your positive slope. So x increases, and so does your y. Now k is a new letter for us. K is called the constant of variation. Can anyone tell me what the word variation means? When something varies, it's different, it's changing, it changes. Is there something else that we've talked about a lot that also means that something is changing? Constant rate of change, which is the letter M. Is that in the same place pretty much as the M? Yes. So the K and the M are very similar in what their functions are. Okay? What's different about a regular function, a regular linear equation, and direct is that the direct has to go through 0. A linear function can go through any y-intercept, okay? But the direct variation has to go through 0. Now, in a problem, you might see this as y varies directly as x. So this one, y varies directly as x, is how it might look. And something that also goes along with this is something that we learned first 6 weeks. Y depends on x. Y depends on x. That may be helpful on your assignment to decide which one's your x and which one's your y.
What does that say when you underlined it right above y?
Y varies directly as x. So that's direct variation. X is increasing and y is increasing. It goes through the 0, has positive slope. Y equals kx. All right, now let's look at inverse variation. What is the equation for inverse variation? Y equals k over x. Y equals k divided by x. Your graph is different with this one. What does it kind of look like? Kind of looks like exponential. The difference between inverse and exponential is that inverse does not ever cross an axis, where the exponential crosses the y-axis, or can cross the y-axis. Inverse cannot. Inverse is not going to ever go through the origin, and it's never going to cross an axis. And with this one, the x increases and the y decreases. And it might read y varies inversely as x. Notice that the y comes first in each one of them. That's because our equation starts with y equals. So if it's direct, they're directly next to each other, the k and the x. If it's inverse, then it's being divided. The k is being divided by the x. All right, so now let's use this to help us solve some problems. There are some steps that we can take to solve these problems, and so let's write down the steps as we do number 1. The first thing we want to do when it says we've got something that varies directly or varies inversely is first decide if it's direct or inverse, and write the equation. Okay, so you're going to decide if it's direct or inverse variation, and then you're going to write the equation. So look at number 1. Is this one direct or inverse?
Direct.
It says it, yes. If y varies directly as x. And so the next thing we do is we evaluate, first of all, we need to write that equation, y equals kx. Then we want to evaluate the equation for k. And what that means is plug in all the numbers and solve for k. And k, remember, is what the number is for the change that we have. Now what I'm boxing are the two numbers that will help us find the k, because it says, I know that the y is 198 when the x is 22. So that's giving us the pattern. We just need to know what the number for the pattern is. And so we put that into our equation and we find out what that k, that number for the change is. So in place of the y, we'll put 198. We don't know the k. That's what we're trying to find. And the x is 22. What do we do in order to get k by itself now? Excellent. Divide by 22. And k is going to equal 9. Now, in the problem, is that what we were looking for?
No.
It says find y when x is 182. We found the k. So what we need to do, number 3, the third step, is to evaluate the equation again. And we're going to do this for the missing variable. So once we use those first two numbers, we don't use those first two numbers again. We use that to help us find out what the k was. Now we use the k and the other one that it gives us to find the missing one. So in place of the y, we don't know. We're going to just put the letter. In place of the k, we'll put 9. Sorry, let's go ahead and write the equation first. So in place of the y is just a y. In place of the k, it's a 9. And in place of the x, it's 182. So we wrote the equation again, and we are solving. So 9 times 182 is 1638. Very good. All right, so how many times did we plug into that y equals kx? Twice. The first time it was to find the k, and then the second time it was to find the missing number. Okay? Let's look at number 2. If y varies inversely as x and y is 27 when x is 12, find x when y is negative 9. So again, the first step is to decide if it's direct or inverse. It's inverse. And so we'll write the equation y equals k over x. And now it says evaluate the equation for k. In order to do that, you have to find the two numbers that are connected that we can find the pattern of. And that would be y equals 27 and x equals 12. So we want to plug in the 27 where the y is. We don't know the k, but the 12 is the x. Now, look at where the 12 is. It's in the denominator of a fraction. So how are we going to make that not be a fraction anymore?
Multiply it.
Exactly, multiply it. So we're multiplying by the denominator. This would give us 324 is equal to k because the 12s will cancel. Is k what we were looking for? No. So we do this again. Step 3. Evaluate the same equation, but this time we're going to plug in the information that's next. We want the y to be negative 9. The k we know is 324. We don't know the x. So that's kind of odd. We've never had it to where it's dividing by an x before, but that x is in the denominator, and we can't have a denominator. So what do we need to do? Same thing we did here, but look at what we have. Multiply by x. Very good. So we're going to multiply both sides by x this time since that's what's on the denominator. Because by doing that, the x's can cancel, and we're left with 324 on the right-hand side, no longer a fraction. And on the left-hand side, we have negative 9 times x.
How did you multiply both sides by that? Oh, okay.
Now, in order to get x by itself, what do I do? Divide by negative 9. Very good. And x equals negative 36. Questions on evaluating a direct or inverse equation. All right, now not always will it tell you the y and the x. It might give you a situation and you have to figure out which one's the x and which one's the y. But we can use the information that it tells us to figure out which one's the x and which one's the y. So number 3, the number of days D required to complete a job varies inversely as the number of workers W on the job. If it takes 9 days for 8 workers to complete a job, then how many workers would it take to do the job in 18 days? So, first of all, we figure out which one it is. Is it direct or inverse? Inverse. And then look at what we said. The problem is going to tell us, bless you, the problem is going to tell us that the y varies inversely as the x most of the time. Well, it doesn't say y, but what varies inversely? The d. The d varies inversely as the w, so we can say that the y is the d and the x is the w. Does everybody see that? Because y varies inversely as x.
And the x is a w?
So the x would be w. So now, since it's inverse, we're going to do y equals k divided by x. But to make it more meaningful to us, we're going to change the y and the x to the d and the w. Okay, so that it's easier for us to plug numbers in. So the d we said was the y, right? So we'll say this as d equals k over, instead of x, we're going to say w. So all we're doing is replacing the letters from the general equation for inverse to the letters that make sense in our problem. All right, so now let's find the pattern. It says if it takes 9 days for 8 workers to complete the job. That's what we use for the pattern. 9 days for 8 workers. So instead of the d, we're going to do what? 9. 9 equals k over, what's workers? 8. So to get k by itself, what are we going to do? Multiply both sides by 8. And this would be 72 is equal to k because the 8's will cancel. But k is not how many workers. K is the constant of variation. So then we write down that same equation again. D equals k over w. And this time it says how many workers will it take to do the job in 18 days. So what is the d this time? 18. The k we found was 72, and we're looking for w. But what do we do to make the w not be the denominator? Multiply both sides by w. Yes. So then this would be 18w is equal to 72 since the w's will cancel. Now what? Divide by 18, and w is equal to 4. There would be 4 workers that would complete the job in 18 days if it varies inversely. All right, questions on that one? So let's do number 4. It says, at a given time, the length L of the shadow of an object varies directly, that's important, as the height of the object h. If the shadow is 27 feet when the height of the object is 12, what is the height of the object if the shadow is 18 feet? So again, it doesn't give us y's and x's, it gives us l's and h's this time, and we need to figure out which one's which. And again, you go back to the original part where we talked about it, y varies directly as x. So which one's going to be the y this time? The L. Because remember, y varies directly. The y comes first. So the L would be the y. That means the h would be the x. So if it's directly, what equation would we use? Kx. But instead of y and x, we're going to use L and h. So this is actually going to say L equals KH. So which two numbers will help us figure out the K? The 27 and the 12, exactly, because those are the ones that are connected. It says this one's 27 when the other one is 12. So the shadow length is 27 equals K times the height of the object, which is 12. So what do we do to get K by itself? Divide by 12. And K is going to equal 2.25. Okay? Now again, that doesn't tell us the height of the object. So what we have to do is we have to plug it back in. And this time it says that the length of the shadow is 18 feet. We found the K to be 2.25, and we're looking for the H. So what do we do to get H by itself? Divide by 2.25. And so H would equal 8 feet. The height is 8 feet. Any questions on that? All right, so number 5 is the same thing. It's just a little bit more of a situation problem here. It says stringed instruments like violins and guitars produce different pitches of a musical scale depending on the length of the string and the frequency of the vibrating string. When under equal tension, the frequency, F, varies inversely with the string length. So how would we write that equation? If it varies inversely, F equals K over L. Perfect. Now it says complete the table to find the string lengths for a C major scale. Round your answers to the nearest whole number. So they've given you the frequency, and we have to figure out the string length. Well, in order to do that, we have to use our inverse function. But in order for us to use that, we have to know what the K is. So how are we going to figure out the K?
Use the one they already gave you.
Use the one they already gave you. Very good. We've got F is 523 equals the K, which we don't know, and the length is 420. Oh, and it's inverse. So what do we do to get the 420 not the denominator anymore? Multiply by 420. Here, I'll write it like this. Okay, so we're going to multiply both sides by 420 so that the 420s will cancel. And so our K is going to be 219,660 for the string length. That's millimeters. 660. Sorry, that's not the string length. That's the K, the constant of variation. We have to figure out what the string length is by using that. But what we want to do, so that we can figure out each of these blanks, we want to come up with the general inverse equation for this. And we're going to put that on letter D. So if we want the general equation, then it's just like the general equation of a linear function. Our linear function is y equals mx plus b, but we put in the general information to help us know what the x's and y's are. So we would say like y equals 3x plus 5. That would be a general equation. So we want to do the same thing here. We don't want to put the F. We want it to be general. We want the K, because that's going to be what we are going to have as our constant of variation. And then we don't want the L. So that's the function, the general function that we would use to figure out the string length if the frequency is given, or vice versa. And so let's figure out what letter D would be. It's giving us the F or the L. It's giving us the F, the 587. So let's plug that in, and I'm just going to put it right here. 587 is the F, and we know that the constant of variation is 219660, and we have to figure out what the L is. So what would we do to figure out what the L is? Yes, multiply by L. So then the L's cancel, and we're left with 587L equals this large number. And then what would we do? Divide by 587. And it says for us to round to the nearest whole number. And so to get this one, it is 374. That's the process that we would use to figure out all of these, but I'm not going to have us do that to save time. So the next one is 333. That's letter E. Then it's 315. Then 280. 250. 222. And 210. 374, 333, 315, 280, 250, 222, and 210. So now we're going to use the information in the table to help us answer letter B. It says describe how the values of the frequency change in relation to the string length. What is the frequency doing?
It's getting higher.
It's getting higher or increasing. What's the L doing? Decreasing. So that's why we know that it's inverse, because one of them's increasing as the other one is decreasing. And then we're going to make a scatter plot, and I'm not actually going to have you draw it to scale. This one's the frequency and this one's the length, and this is what it ends up looking like. So what kind of a correlation is that?
Negative.
A negative correlation.